Right guys, welcome to a very interesting video. So I personally drew this shape myself, so I hope you guys like it. So what we have here we have a circle, a perfect circle, and inside circle is a square, ABCD, inscribed within the circle. And here we have the radius from here to here of r equals 3. We also have 4 equally sized petals, which are actually semicircle arcs, or sectors if you want to call it. The idea of this problem is trying to use all our mathematical techniques to find the areas of each part of the region. So we'll find the area of the white part, the green part, and the orange part. So how do we do this? Well, let's consider an arc. Okay, let's consider a small sector. So let's decide to split this across here and call this length, and then we'll take out this shape. So over here we have a petal. Okay. Without working this out, we need to consider how we even describe the shape. Well, what we could do is imagine the shape as a semicircle, or at least part of a circle. In this case, 1/4 of a circle, and it's literally the sector of it. To work out area of a sector, it's always going to be the angle over 360 times area of a circle. So the area of the red part is going to be, so of course area of red is always going to be area of so it's going to be, what is it, 90 degrees, so it will be 90 over 360 times pi, and we're going to call this length x, radius x, pi x squared, and this summarizes to pi x squared over 4. Now to get the white part, it's literally the area of a square minus the red region, so the white part, which we're going to label here, equals, so we call area white, the area of a square, which is x squared, minus this value here. Okay, here we can even factorize, so we're going to get x squared 1 minus pi over 4. Cool. Now if we're going to rewrite the shape as it was over here, which is 2 sectors, which is a petal, so let's call this a petal, and this is going to be the green part, and of course we're still with the same lengths, xx. This is literally 2 white areas, so we literally double the white area. So this region here, we can call it 2AW, and 2AW is simply double this value, which is 2 lots of x squared 1 minus pi over 4. And now referring back to this shape here, notice we have technically 8 quadrants then of white areas, so 1 2 3 4 5 6 7 8. So using our equation, we can call this part 8AW, and this summarizes to ax squared 1 minus pi over 4. Easy, isn't it? So now we've calculated that part. Let us move on to the petal. Okay, so we have the area of the white part. The petal is more or less the area of a square. So the petal is pretty much this value, and we're going to minus it again from the square. So square minus 2AW. So let me just make this board a bit cleaner because it's quite condensed. Okay, so we don't actually need this part anymore. Well, okay, so far this shape here, let's just summarize it here, is a 2AW, which is 8x, so 2x squared 1 minus pi over 4. Okay, so this is this part, and we know that the petal itself, now the area of the petal itself, so we can call it AP, is going to be the area of a square, which is x squared minus 2AW. Think about it, minusing the 2 white parts. This can be summarized as x squared minus 2x squared 1 minus pi over 4. We can leave it here just for convenience sake. Now the next part, so this, now we knocked out the difficult bit, so now we should consider finding the orange part of the region. Okay, so this is quite straightforward. Recall that the radius of the circle is 3, so we can just subtract the entire circle from the square itself. So therefore the area of the orange part is simply the area of the circle, which is pi r squared, so pi 3 squared, remember 3 was the radius, minus the area of the square, which is x squared. Now the question here is, what is this value of x anyway? What is the value of x? Well, the value of x itself, if we consider, let's consider this triangle, because we know that x is this length here and r is a diagonal here. So taking out this triangle, okay, we have an x here and x here. So let's try and define what this value of r really is. Using Pythagoras theorem, we've got x squared plus x squared equals this value squared. So x squared plus x squared equals r squared. Therefore, we have 2x squared equals r squared, and square root on both sides, r equals the square root of 2x squared. Or to make x a subject, alternatively, we could divide by 2 and then square root. So we're going to have x equals r squared over 2 square root. And yeah, so replacing r with our radius, we literally have the value x to be. So r was 3. So 3 squared, which is 9. 9 over 2, which is 4.5. So it's root 9 over 2. And that's it, guys. I mean, substituting this value in, you're going to pretty much get every other value here. So, yeah, that's literally it, guys. I hope this video helps. And if you've got any questions about how we got such and such, you know, just pin me a comment below. And yeah, I hope this pretty much clarifies how to do everything. It's a lot of calculations here, but really and truly, it's a very straightforward task. But yeah, guys, ciao, and I shall see you soon. Bye-bye.